welcome everybody. Welcome students. Thank you for taking time Monday and joining this session. My objective of this session would be deep learning is newly evolved. Newly in last few years, deep learning has truly involved in solving many our day-by-day life problems like image recognitions and you could have seen chatbots and like say when you go on a phone and you have this face ID unlocking, there's a deep learning concept. You go anyway, there's a deep learning actually doing that. Would not you be interested to know how those stuff work? My objective would be to give you institution of deep learning architecture, without getting into mathematics or deep technical concept. I tried my best to keep it that level, but it cannot be avoided to go a little bit technical and use some jargons. But that was my objective, that you learn those jargons and deep learning, I just say everywhere. And so you recognize and, have some fun with that and see how the complex problem gets solved by, this magical concept called deep learning. At the end, I'll definitely leave you with some tips where if some of you might get interested and you want to develop your own basic model. I'm not going to teach how you develop that in this session. 1 hour is very short for that. But definitely tips where you can get started and how easy can be to you if you just want to get started. I mean, I will leave you guys with that thought. You can ask the questions anytime. In between, I'll take the questions and I'll reply to you at every milestone on the conversation. Quickly, without ado, let's dive into the deep learning. Why it is popular now? The concept was there for a long time. Deep learning is built on neural network. A neural network concept exists at least 30 years back. As the cost of computing has come down, as the storage cost come down, and now we have all these devices like mobile phone and all this digitalization happening around. We have large amount of data. Now we can process those large amount of data in a cost-effective manner, and that's why deep learning getting popular. By the way, deep learning I'll say is more a marketing term. Underlying concepts and neural network. And you can see this graph, which is you have is that more data you have, the deep learning keep getting better. Traditional learning algorithms like random forest and others, they get flattened after some data. So it's the deep learning which truly takes the advantage of data available today in the world. And data is called a new oil, but I'll call it data is everything nowadays. So deep learning becomes very important. And eventually, I think as a student of whichever branch you are, it doesn't matter you are in computers or non-computers or electronics. I think eventually you will have to learn learnings in some of those concepts, coming for in time, because this technique is going to go everywhere. So what's the deep learning then? Deep learning is a subset of machine learning, and artificial intelligence is a big concept. When you talk about artificial intelligence, you can have an intelligence based on a knowledge repository. You can have mathematical equations has some intelligence. Machine learning is a way to get those intelligence. I'll talk about a little bit in that. And deep learning is a subset of that. And as I said, this is inspired by probably how the brain thinks. It's called the area called neural net. Okay, that is where it is inspired by. What's artificial intelligence? Like, there are many definitions of artificial intelligence. If you talk about if you come to paper or newspaper everywhere, to me, the basic is that how you teach computer, how you program a computer, do a stuff which as a human we do it very easily. Like we see something and we recognize, even if we have not seen that before, or even if our guesswork, our understanding. I'm talking now, and you can understand what I'm talking about. Those are the things human do it very easily, but it's very hard to teach computers. So how we program something that computer learn for the task which human does easily. Okay, and key goal is to automate. Goal is that how we automate day by day stuff as human do. I mean, that's goal of an AI. As it meant we have to go through his documents and how I can automatically summarize those documents, things like that. People has applied AI on. So let's get one deeper level and towards our journey on understanding deep learning. What's a machine learning first? Just to make sure that we are on the same page. Some of you might be knowing these. When you talk about a traditional programming, you have a data and you write programs and you get the out. When you go about machine learning, what is happens that you give a data, it also takes the output as an input to that and creates program. And as time goes and goes, what happens that time learns from its own mistake and then improve. That's a learning, right? We as we grow, we learn, we grow. We call it experience, right? That is what the machine learning is all about. So that's the inputs of data and output, and it improves its program automatically. That is what the machine learning means. And a machine learning, and this is something I would like you to pay attention to. A machine learning algorithm depends that how you are representing a data. You will represent a data like, say, for example, if I'm talking about Amity University, then there's the name of the university, there's the places, there's the campuses, the site of the campuses, number of the students in it, number of professors in it, supporting staff. So there's various stuff is about Amity University, and you get that data, and how you're presenting the machine learning algorithms depends on that. And that is a key of data science, actually. The data scientists are trained, take a data and make it a machine learning learnable. That's what data science is about. It is the information which you create in that data representation called features. If I talk about Amity University, there is a multiple aspect of it, right? So many aspects of it. Can I, as a humanly, go and find all those features? It's very difficult in some time. If we talk about image analytics, right? An image has thousands and thousands of pictures, as a human. That has been a kind of blocking in past, and we can't escape. That's a very key thing to get into the deep learning neural network for you to keep that this mind, features and representation learning. What happens? Deep learning automate feature extraction. Pay the attention here. I got a car. A feature extraction is rules have been written by a human who is a data scientist, and the classification happened. Is a car or not a car? The classification. Deep learning is done. The feature extraction and classification is embedded in the algorithm itself. That's a human element has gone out. That's a key contribution of deep learning concepts to the intelligence on AI. Go a little bit deeper. What we're talking about? Yeah. So there's a question on feature classification. So it's not feature classification or truth aspect. The feature is how you represent a object. So this is a car, and there's a multiple features. There's a color, size, etc. These are the features. Okay, and I'll talk a little bit more about it. Is how you describe a car. That's a feature. And the classification is now you have trained your model. Now you give multiple objects. There may be car or motorcycle or cycle or some algorithm identify that it's a car. That is what it's doing, car and not car. So this is a two term. There was a question there from the audience. Now we go a little deeper, one step deeper. Okay? When we talk about deep learning, it happens in layer. That's a key concept, deep learning. So if I have this image and I have to identify that is a person, what happened that, and don't worry if you just don't get it right. Next slides, I'm going to extract it more. The first layer is the input layer. Takes these features, these all pixels it will take. First hidden layer is called hidden layer, will identify the edges of this person. Second layer will identify the corners and etc. Third layer will identify the other object, hands, and finally it will conclude that is a person. What is happening is a layer, and that is so a deep learning divides a problem in multiple layers, and each layer does its job, and finally it identifies the object. That's how the learning happens. Now we'll go deep one more layer, and we'll see how these layers, what the concept these layers are. What happens is, can you see this perceptron? These are the one which these layers stack multiple layer, get the output, and that is why it's called deep. You're going deep in that. That's why it's called. So what happened that these are the perceptron, and how the perceptron look is very simple. X0, X1, X2 is the input. Until we wait, you multiply it by that, add some biasing, apply some function. Typically is a kind of, like say if you want to have only positive numbers, depends on the problem. You have some output which goes to a next layer. That's all happens. Okay. I have this perceptron. I get input. Let's zoom on one. You will get a sense of. And please pay attention to it. This is a very basic. Go next. So you see that I have a weight W1, W2. Somehow I'm summing it. Signite is a function which If you have anything negative, it will make it 0, and I'm passing to next level. That's all is happening. If I go back layer here, this layer will do the same aspect and move it to here, move it to here, move it to here. In the process, what has happened, that it will learn what the weight should be. That is a learning. It's an algorithm called back propagation. I'll show that. So let's say these features in different layer becomes non-describable. It's not relevant to describe the object. Then weight becomes 0 automatically. Or in next layer, this layer become more important. The weight will increase. That's what happened. And magically, this network learn. You see, this is the network structure. What it is called is a feed-forward network. That's what it's called. Yes, I will come to algorithm. Okay, can't go very deep on this small set of questions on can I explain the algorithm. Be hard in a game time period, but I will say let's pay attention to the institution, and then if you have interest, you can go look at those algorithms for detail. But I'll try to touch base on. I will say this is a perceptron. So what happens then as an algorithm, just to basic, I calculated something based on this perceptron formulas, move it to next, I get output layer, and I will have a loss function here. And my objective is that, say I'm identify human, I reduce my error. What I'll do, I'll go back again this layer. You can follow my cursor and re-evaluate all those weights. And then again, I will train the model and evaluate my loss function. So that's how the algorithm works. I'll show some animation on that. Typically, loss concept where, and then depending on the problems where you will pick different loss function. That's what is my yi and what I am expecting. That's a learning process. Objective is that I want to minimize the loss or error. How that works? That works through this back propagation algorithm. What is happening here? That I'm going from layer to layer, and there is a weight. The weight and biasing, which I was showing it. I go layer to layer. I calculate my loss function. I see, did I achieve my objective? No. Then I go back and readjust so that I can minimize my loss. And this process keep going. In some cases, you might have to do 50 times, 100 times. The loss function eventually converts. This is a basic algorithm for any deep learning. So you see that I have an input, I have a weight, I have a bias. I calculate here, move to the layer, calculate my loss function. Loss function is not at acceptable level. I go back, you see that, DW, right? DW is, I will increase in certain level, positive or negative, so that overall the loss function keep going, getting less till I reach to my desired level of accuracy. This is called back propagation algorithm. There's a forward propagation, and there's a back propagation. There's a question here that is that always give me the best or optimal? The deep learning or any AI algorithms always give the estimates and optimal solution. It never gives a best solution. That's where the loss function comes, and your objective would be that how much I minimize it. But you cannot achieve 100%, and that's not just doable. Objective of AI deep learning is the estimation. It's an optimal solution. It is not the the best solution. Not necessarily is the best solution. So, moving forward, the basic what structure you see, this structure is called multi-layer perceptron. That's a term, multi-layer perceptron. Multi-layer perceptron is the basic. This is used for classification regression problem. It's a classification. Some object is a human and not a human. Yes and no is a classification. Regression, where you are predicting some numbers. So what will be temperature tomorrow is a regression problem. So MLP is typically used for classification and regression. On the top of it, number of variations have been developed architecture for a specific problem. And today I'm going to cover 3 of them. I can't cover everything, which is the most basic. The most basics are CNN, called convolution neural network, used for image processing. I'm going to talk in length about it. Recurrent neural network, where you have to do a sequence modeling. Okay, auto encoders, where you have to data compression, anomaly, etc. Okay, GAD, generative adversarial network, used for generating text, image. You might have heard, AI has written some movies or generated some pictures. That's what does. So I'm going to cover a couple of them, which are the most basic and fundamental. So moving onward, let's talk about image analysis little in depth. I have to do image analysis that I have to identify swarm on the picture. I can get picture in many ways, and see, this is swarm. these are the features which is red, can be probably used to identify the swarm. So my algorithms would be able to recognize it. Now this swarm can be in any form, right? He's flying here. You can see I only see the eyes in the car. You see that? And these images are tough to see as a human, right? That's why purposely I have put it here. These are images, see, only I'm seeing the neck. So I can get only I'm seeing the tail. I can get any kind of images, right? As a human, we'll able to recognize that, but we have to teach computer. So let's see. I might have different colors, and then and even get worse. You can see that how this is the kind of try how you differentiate that, right? So how we teach computer, and as a human we can identify, right? So our objective is that computer behave like a human. How you do it, right? In past, researchers have built multiple, computer vision techniques. I'll not go in detail. It's a handmade kind of, of recognizing the image. But as I said, whenever a human has done, it is, simple or very hard to generalize. Means that, any unknown data, the algorithms should look at and understand that, right? That is what ultimately the goal is. As a human, we do that very well. Can I learn features detection automatically? Can I create a system which can do a representation learning, like that feature learning? I talked about representation. So how we do that? Traditional method has a challenge that's like if I learn to identify swarm, but what if this swarm is here? Then those algorithms fail. What if swarm is on the right corner? Then the algorithm fail. That has been a limitation of traditional way of doing computer, vision. Last couple of years, different architecture has been developed. In last 2-3 years, there is amazing revolutions on image analysis and video analytics. You can see some tremendous application on mobile apps. You can change more for the image, or on CCTV camera, you see everywhere on the road, on traffic violations, automatically identify the traffic violation. How that magic is happening, you're going to learn that today, right now. So it happens with the concept of convolution neural network, or CNN. Works is it takes all the source pixels and apply a filter. It will apply in this filter, put these values, for example, and it will go through all these, okay, one by one, okay, and create the feature map. That is what happens. So what is the filter? These are the filter, concept of filter. I have this image. I have applied age detection, and you see how the image has become. It identify all the ages for me. If you can see the right side picture, or I need to sharpen the picture. So I have this like very dull picture. I have edited, put a filter, simple, very similar. Whoever is in a photography, you can apply different kind of filters in your camera and image changes. You are doing it digitally. That's what's happening. So you will add different filters in a layer, actually will create the feature, because my objective is to get the feature automatically. That's what I'm trying to achieve. Remember, this would be a very, very large data. Finally, I will have a network like this. So quickly, I have this input. I have the convolution layer, the one which I talked about here, by applying different filters. Coding is a way to select what feature has been, and I created a feature map. So I will add multiple layer like this. Finally, I will have the features, and I'll put in a MLP, the multi-layer perceptron. That is called fully collected. That will actually do the classification. So this part, left part, which you see feature map, pooled feature maps, convolution layer, this is the part which generate the feature map out of the images automatically, so that it can scale. That is the called CNN, convolution neural network, a variation of the basic neural network. And this architecture magically take care of all these variation of images, magically learns that. Because of the magic of this convolution network, it goes through, because this filter is detecting every corner. It is going one by one. It's scanning that entire picture. So it knows where is the relevant feature is. That's why it is able to achieve. So it's called CNN. Basic concept. There are a lot of pre-trained deep learning models are available. Want to get started in image analysis. Without you knowing tail of how it goes, you can actually get started. For object detection, these are the mass RNN, YOLO, MobileNet. These are the publicly available pre-trained models. You can go download it. Facial recognition called BCG, 3D, or segmentation. These are the practically also, when we in the industry, practically also, we cannot afford to have these models built from the scratch, because required millions of the data set and maybe like 20 or 50 computers to process it. As even organization like Quantela, we cannot have that much resource. So we'll always start with some publicly available pre-trained model, especially for imaging and video analytics. And what we'll do is that there's a technique where I can freeze layers, 1 or 2 layers, and retrain that layer on my own data sets. I mean, that is how the practically it happens. Or any of you interested to play around, you can go download these facial recognitions and you can apply in your application without knowing much of it. There is a question that the convolution network is always right. Does it mistake? Actually, it does a lot of mistakes. And none of these techniques can be 100% perfected, as I said. There's always a lot of false positive, false positive. Does happen. And when we put these techniques on the practice, we actually try to put some kind of process inside that if any mistake has happened by CNN network or something, then how we deal with it. Okay, we always put some kind of fallback. And what we also do as a platform, we kind of create a feedback mechanism, so we know that a model has done some mistake. And also one more point I'll add it. There's something called model drifting. What the model drifting is, that model also has a life. When I deploy a model, with time may increase its learning and perfection, and then it can start decline. And what has to happen, that model has to be relooked. Might have happened, the data pattern might have changed. The model has to be rebuilt there. Okay, so model has a life cycle. Model does a lot of mistakes. So we always have to plan accordingly when we are deploying in practice. Good question, whoever asked that. So moving forward, I covered your image and video analysis. Now moving forward, sequence modeling. In our day-by-day life, we come across many things which is sequential in nature. So like if you look at this, what is a sequence data? Left side, this is a ball. Can you predict this ball, which direction is moving? You cannot. Have a snapshot of this ball like this on the right side, then you can say that this ball is moving in the right direction, isn't? And that is a sequence. This is a sequence data. So what kind of example you have a sequence data? Like audio. This is the audio. You have a different kind of form of audio. Text, language is a sequence. If you have to understand the language, one of the objective of deep learning, then you need to know how I can sequence the data. This ball, predicting this ball, the direction depends on its previous snapshot. So somehow my neural network has to have that ability to know what has happened in the past. How that can happen? Let's talk a little bit about that. Yeah, there is a question that can I share this PPT with you? Definitely, I can share this PPT with you, and I'll ask the host that how I can share with. I know these concepts are extremely hard. Not many people, you can't get it in this 1 hour session. If you can review later, you will get it. How I can take a feed-forward network we talked about. You have input, we have hidden layer, we have output, and add a sequence to it. What we can do is we can create a loop. When the output has come, that also becomes an input. That is what is happening here. And RNN does exactly that. What is happening here, if you look at here, I have created an RNN, and I am telling RNN, last 7 data, 11 state is also input to my model. Not only I have this x1, x2, x3 as an input, but I also have the outputs as an input to it. So I can know what has happened in the past. So if you see a bottom, right, it has a looping mechanism, so essentially like a for loop, and then it created multiple layers. This is called recurrent neural network. And all these actually get input to my forward neural network. So forward neural network, this is what you see on the left side top, is the basic, right? Only how the input is going to it is I am trying to create a different mechanism. CNN was a mechanism to create this input. RNN was a mechanism to create the input list from my past experience. Okay, that is the RNN mean. Now I have a way that I process a sequence data. I can model a sequence. What is there's a question that there is can I call Google Map as a sequence data? I think that was a question. No, Google Map is not an RNN. We can't call it a RNN. Google Map falls in a different kind of kind of machine learning and all. It's basically a geospatial data science. It has a location intelligence. That's a very separate, area. And I'll not classify Google Map as a RNN. They might have used certain RNN technique, which I'm not aware of, but essentially that is a location intelligence and geospatial data science. That's a separate, area of study. At Quantela, we use it very heavily in doing some of the smart city projects. But in Quantela, for example, we use RNN very heavily for the time series kind of data. So we have IoT devices, and they are sending me data continuously for a location like pollutions or temperature or something, and we have to forecast for the next day or something, right? That becomes a time series problem. RNN are typically used for time series kind of modeling, natural language processing modeling, natural language understanding. That's where the RNN come, where you have a sequence data. That is the sequence. Now again, I wanted to give you little things which you can get started if you want to get started right now without knowing much of the basic concept. So somebody, if you want to do some NLP based processing, add some intelligence to your, there is some very powerful trained models are available which you can download. The Google BERT is supposed to be one of the revolutionary one which has been made public. Transformer, word embedding. You have to want the meaning of the words. You can actually use them actually. Okay. Stand for NLP, like I have a sentence, like say call, Amity University, located in Dubai or Noida. So the word Dubai and Noida, whether it is a city or a country, you can actually automatically identify a sentence using the stand for NLP. So these are the models. If you want to play around or want to have some fun quickly, you can become an NLP. You can impress your friends and the colleagues that your application intelligence can process NLP. But behind all this model is RNN. That is something you can understand. You will see the Google chat bot on the websites. This is last architecture which I wanted to share with you was a autoencoder. Autoencoder is a very strange type of network. Why? Because when you are making this network, your objective is that your input. So autoencoder is a very powerful network and very strange kind of, because your idea here is that I take an input and then I decode it and bring to a original input. So the input and the output should be same. But as it happens in any network, there will be some loss. Okay, so you see that there is an input, it's very sharp. The output is little bit dull. So there's some losses happen, and this is called autoencoder. You encode the input, get some code, use it and decode it, and get the output. I'll show you what kind of use cases it solves. What an autoencoder is, essentially, your encoder is another MLP, is an artificial neural network, multi-layer. This is an encoder. You got some code, becomes an input to another multi-layer, MLP, and you will get the output. That is a basic structure of encoder and decoder, autoencoder architecture, which we talk about. So what's the benefit you get by that? The benefits are multiple. Image reconstruction. You see on the top, these are images not so clear. Now this image is actually a shoe. It's a bottle. Some kind of reconstruction of the image from broken image something. Image denoising. If you see this on the top image, you see here the black one, the 2.8, you cannot even read it because there are a lot of noise, has gone into that picture. After doing through encoding and decoding, you have cleaned it, because what has happened, as a network has learned the good and it has not learned the noises. So when it is recreating, it is able to give a clear picture. Okay. In mobile phone, there are some mobile apps where you can actually have a picture and demorph that picture. That is also the autoencoder. The other one is the data compression. Right. So the inputs are so many, and this code is able to reconstruct this input by itself. Right. So it's a data compression. You have this much input right now. If you see left side, this much input, it has become a smaller one. Or anomaly detection. How it works is that if I have a data, I have built this network, my output are now if I give an input which is not according to my previous train input, then I'll be able to flag that out because the reconstruction will not happen properly. That becomes anomaly detection. That's a use case of auto encoder. There's a tremendous use of auto encoder. So the students and faculty, I have covered some basic architecture of deep learning, which is heavily used most of places. There are many more architecture. Every second day, some new architecture come, or which are mostly the variation of those. So like if you talk about RNN, then there's something called LSTM, right? It's a variation of RNN. There's something called attention, that is a variation of RNN. So most of these new architectures, somewhere is a variation of these architecture, which I have just talked about. I come to the end. I wanted to leave you with some note if somebody wants to get started. Typically, a Python is a preferred environment to do any kind of deep learning kind of development. Keras is the most widely used library you can use. They can work with TensorFlow. TensorFlow is a framework for deep learning, or PyTorch, or any other. So learning the Keras library is a good starting point. It's very simple to create your network using Keras library. If you have a system with GPU, is preferred because they are very heavily mathematical computing, processes. It cannot perform well in CPU. You need a GPU-based system to perform it, efficiently. If you are doing a classification or regression, use MLP. Straightforward create MLP. If you want to do image or video analytics, use some pre-trained model to start with. And similarly for NLP, if you want to do NLP, good to start with a pre-trained model and customize for your need. This is my tip for you if you want to just get started and try out something on deep learning perspective. All right, so I come into end of my presentation. I mean, this is what I wanted to share. I'm going to open for the questions next 5-10 minutes, whatever we can have a question.
So all the attendees, please, you can type the questions in the chat box.
Yeah.
So, sir, there are few questions I will read, and just there is one question: will deep learning always provide a good solution, or it can also be used to get optimal solution?
Yeah, so it is always used for optimal solution. Not necessarily it will provide the best solution or good solution. Any deep learning algorithm, CNN or anything has a certain error factor. That's why we say when and the folks even you go in a market or something, say that my algorithm work with 90% accuracy or 95% accuracy. None of the algorithms are perfect; they are optimal.
So there is another question from one student, Mohammad Jihad. He's asking, the machine learning is a type of feedback focused arrangement. Is machine learning?
Yeah, I got the question.
Yeah.
So in a machine learning, the feedback arrangement is very important. Okay, so that's a good way to put it. So when a machine learning algorithm gives an output, and then you have a mechanism to see that my outputs are accurate or not, or is it within my permissible limit. That input goes back to machine learning, and with the experience, machine learning improve. Okay, so there is always some kind of feedback mechanism how you improve your algorithms. That's the way you learn. Learning mean that.
So there is another question from one of the student. This CNN feature, is it always accurate? Does it make any mistakes?
It can do mistakes. Actually, it does a lot of mistakes. So a way to measure that my CNN algorithms are accurate is called how much false positive I am giving. Let's say, for example, there is a CCTV camera put in some gate to identify a person or attendee. Okay, how much time it is accurately able to identify is a positive case. How much time it cannot is called negative case. Generally, 10 to 15% false negative is very, very common.
There's a last question from one of the students now. They're asking, sir, to that deep learning is subset of machine learning. So what is the prerequisite for that machine learning?
Yeah, that's a good question. prerequisite for a machine learning is that you should have a data. Okay? So because machine learning learns from data. So and data called training data. So you should have a certain data set available with you with a known outcome. That is a starting for a machine learning algorithm. Now, machine learning algorithms themselves are two types. It's called one called supervised learning and other called unsupervised learning. If you are doing a supervised learning, then you need to know what the outcome to be expected. Okay, that's a supervised learning. There are certain cases of class of algorithm where the outcomes are not pre-known, but it can do something like like clustering kind of algorithms. So it will cluster those data in certain ways, arrange data in a certain ways. The autoencoder, which I have shown, is actually a non-supervised learning. But to start with machine learning, you need a historical data. That is the starting point for machine learning. Could you give an example which does not include image and video analysis? Okay. One reason of putting image and video in this conversation because AI means that. Okay, but you can have an example of time series modeling, for example. So I gave one example of IoT. IoT devices will give you a data continuously. Right? So you have a time stamp and you have an observation. Let's say you have an environment-based sensor. So every time 1 o'clock, it has given that carbon level is this. At 1:30, something else. Your job is to create a machine learning algorithm to forecast what will be next day, what will be after 1 week. That you can do through RNN and RNN kind of sequence modeling. So there is no image and video analytics involved. That's text analysis, NLP. Those are all examples of those. Another question I have here is that how classical encoding and decoding is different from autoencoder. The autoencoder learned by itself. The classical encoder and decoder, you actually give a rule to it that how you're going to encode something or decode something. But autoencoders are actually a learning algorithm. So you're not giving a rule to it. You are giving a data. Through that data, it is figuring out a best way to encode and decode it. So that's the difference between classical and the autoencoder. Okay. As I said, classical is a rule-based. Autoencoders are the self-learning algorithm. All right. Another good question called, can you provide an application example of deep learning machine learning in your work life in Quantela? Great question. In Quantela, it is a smart city. I work on a smart city domain. Okay, so what kind of things I work on? Like solid waste management, traffic management, then parking, lighting, smart lighting, property tax management, things like that. Okay, and there is a tremendous application of machine learning in that area because if I take an example of solid waste management, there's so many factors involved. If you try to put a rule, it's very difficult. Then you have to put some kind of machine learning algorithm. What kind of things, for example, I do here? Like I have a garbage to be collected in a city. Can I give an optimized algorithm to pick those garbage so that the wastage of time and the fuel is reduced? For example, I have a smart bin. Like these bins actually tell me that how much it is fill up. Can I give a forecasting for next day that which bin will be full, fill, so that I can plan for pickup, for example. Okay, parking, for example. Can I give a forecast for parking? That is what would be occupation level next day, so that I can do dynamic pricing on it. Okay, and we do a lot of satellite imaging also. So satellite give an image identifying object in that satellite image. Lot of CNN-based programming we also do at Quantile. You think the deep network is better than a shallow one? See, look, a great question again. I think it's a great question. The simpler the model, the better it is. Okay, it really depends on the problem statement. Now, if you have to just solve some kind of a simple program, a problem of giving a sales forecasting for next day, okay, where it is taking a sales data and doing the forecast. it is better to stick to some classical methodology called ARIMA and time series forecasting. They are doing deep learning doesn't make sense. But let's say I have to do a, weather forecasting for next day. Now, weather depends on multiple factors, which is the location, where it is, how it was before. There are so many factors involved in forecasting a weather. It's a complex problem. Okay, there we have to have a deep network. Okay, where the object is complex, like images and all, there we have to have a deep network. Depending on the problem statement, but as a practitioner, I always advise to look for simpler one and shallower one than jumping to deep learning. Sir, can you tell deep learning real life example? Definitely. If you all are using mobile phone. There are so many deep learning examples in the mobile phone. For example, you have this face ID. You look at your face and it get unlocked. There's a deep learning algorithm behind it. So, website, I was talking about chatbots. If you go to some banking websites and some other places, many of these chatbots are deep learning based. Okay, there's no human in between. They will do automatically. The worst case, only human will interfere. All right. Deep learning is a subset of MI and ML is a subset of AI. That's correct. That's I said in very beginning. Deep learning is a specialized machine learning where very complex object has to be learned. Okay. And in the previous question, I talked about shallow versus deep. If you have a shallower problem, use the shallower one. If you have a complex object like languages or images and that kind of videos, then you have to learn do a deep learning. It's a subset of machine learning. Yeah, there's a question: deep learning is subset of MI or ML is subset of AI. What do you mean by subset? Yeah, sure, good question. AI is an umbrella. Artificial intelligence umbrella. There's many ways to do AI. Okay, in past people have put the rules. Okay, if this X happened, then do Y. That is also a knowledge representation. Okay, so there's many ways to do AI. Machine learning is one way to do AI. Okay, not all. In some cases, for example, Quantella, we do some mathematical formulas we create or simulation we create to create AI. We don't use ML. Maybe data is not there or some other challenge. Okay, so you take machine learning. Now, machine learning can be done in multiple ways. There's something called random forest, logistic regression. There are many other classical way to do machine learning. Okay, and deep learning is a way to do a neural network based. So this is one type of machine learning. There are many more type of machine learning algorithms. That's why I use the word subset. Can you give example of Python programming in real life? Not sure what that means, but many of the Python is one of those fastest growing programming language. It's very beneficial to use in any kind of application, just not AI based. If I could give a real life example, is question not so relevant in that perspective. This is another very good question. Can unsupervised learning be used to generate a training data for newly developed machine? Very good question. See, any machine learning has a difficulty of getting a data, to have a data availability. So there's many ways, and many of these, deep learning is a very, very data hungry. Okay, so how you deal with that? Unless you are in Google, unless you are in Microsoft or Facebook, you will not have that massive amount of data. Okay, so there's some concepts called upsampling. There are many ways to increase your data. Okay, there's something called GAN. It's a generative adversarial network. It can take few images and it can generate more images for you. Or there's something called image augmentation. What it does that it will generate multiple images, taking one image as an example to create more learning data for you. So absolutely, yes. Unsupervised learning can be used to generate training data for newly developed machines. Absolutely correct. And that's a very good way to improve the accuracy of your network. Okay. Is there some specific software that you use to work on those projects? I'm working on my final year major project related to managing traffic system using MATLAB. See, in our company and most of the places I work, my job is to develop platform. Okay, my job is not one time. I have a platform and I have to make it, things automated and deployed customer places. So we use heavily Python and Python-based ecosystem. But people like, probably yourself or somebody is, in a medical professionals and some other places where objective is not to develop platform. MATLAB and some of the tools are very good to use. Like you have like, IBM Watson, or there's some freely open source like Rapid AI. There's something called Rapid AI. If you are not in a job of platform development, you can leverage these software available open source to do some AI and some other work for your own purposes. Okay. In my profession, I use very heavily Python because my job is to develop platform. The next question is deep learning playing any role in cyber security? Very heavily, very heavily. Anomaly detection I talked about, this auto encoder, heavily used in cyber security to identify some pattern which is not normal. And auto encoders are great for that. So there is very heavily used. Here's the contact details. I think I will skip that. Prerequisite to learn AI ML deep learning. Okay, this is a great question. Ms. Jaswal. It really depends on what your objectives are. That is very important. What my objective is. Am I want to become a professional and hardcore professional in deep learning, or I want to use deep learning, or I want to use AI or ML? Do I want to leverage AI ML or deep learning? Okay, that is one aspect. I want to become a practice deep learning. I want to develop a architecture of deep learning. That's a two aspects. So let me answer this in two ways. If you want to become a hardcore AI ML deep learning professional where you actually developing the architecture, you need to have a very good understanding of statistics, linear algebra. These are very important. That is a basic starting point. It's extremely important for you, and you should be able to do some programming in Python and R. If you want to leverage this concept, AI, ML, and deep learning, then you don't really need to do that much of mathematics. You should know what I just shared right now. You should understand when I say what is CNN, then you should know where it can be used, where it cannot be used. If I say RNN, you should know where I can use, where I cannot use it. There are many software available right now which give this as a pre-built. Okay, so you don't have to write a code. You have your training data, learn it, get the output, and put it as reporting or whatever your purpose is. It really depends on that what is your purpose. If you want to a professional AI ML deep learning, then you have to have mathematics, you have to have very good domain knowledge. You don't need to be a computer engineer. In fact, in my team, for example, I have a 15 people team. I only have 2 computer engineers. I have people from a various background. I have people from geospatial background, the medical background, civil engineering background. So all kind of, and for a purpose, because I wanted a very diversified team. If you become to be a professional, any profession you are, any of your stream of learning you are, you can actually become a practitioner AI, ML, and deep learning, guys. While because there are a lot of students here, I also tell you that how I hire in my team. I never hire in my team because you have a computer science or something like that. I hire in my team students. I hire a lot of students and interns who show certain, inclination towards data and machine learning. They have done some courses, online courses. They have done some project of their own interest. Those are people I hire because there is no very good courses. Courses on universities are still evolving. Still they are coming up. So normally in my company, in my team, I always look for students and people or interns who show certain inclination. They have some evidence on resume, irrespective of whatever majors has been. Okay, so as a student, my suggestion would be if you have interest, don't get bogged down that I'm an electronics guy or mechanical guy or like that. All of those has a place in AI, ML, and D. Look at that way because it's going to get applied in machine. I hired civil engineers because urban analytics is all about civil engineering. Smart city is all about civil engineering. I myself, when I started, actually I read civil engineering. All right, guys. So that's all I think from my side. Bhupender sir, I think there is no question anymore.
Yes, I think, sir, you have given a lot of answers from the students. They have asked so many questions, but I think that it was a very wonderful lecture. I have seen the interest of the students. How many questions they have asked actually. So, sir,
No problem. I can stick around. No problem.
So thank you once again, sir, for a wonderful lecture, and thanks for that you have given a precious time from your busy schedule. So I think I would like to conclude this session now, webinar. Thank you, sir, once again.